And now going to part C. Part C is given as y equals to x power 4. So what do we need to do? The formula states that dy dx equals to limit as h tends to 0 for the function f of x plus h minus f of x divided by h. So what do? Let us find f of x plus h. Let us find f of x, and then we substitute for them. So this is the function y in terms of x. So we just say let the function y be the function f of x, which are the same, because the function y is in terms of x. So therefore, f of x becomes the function x to the power 4. We have f of x, which we need here. Now the next thing which we don't have is f of x plus h. I said earlier, in f of x plus h, you simply come and substitute. Where there is x, you put x plus h. That means here, this function here, we shall have, instead of x here, I'm going to write x plus h, and then to power 4. So that x plus h corresponds to x alone. So we simply need to expand x plus h power 4. So on expanding, now let us first expand x plus h power 4. You can use either operation of brackets, plus triangle, binomial expansion, and get the same answers. But let us use a quicker one and the one which is easier. So we operate the brackets. What does this mean? This means that we need to multiply x plus h by itself 4 times. Now that is the same as x plus h times x plus h times x plus h times x plus h. So that means I'm going to multiply this and then I multiply them again. So let me start by this 2. Here we'll have x squared plus 2xh plus h squared. That is, we have used these two brackets. And then I'm going to again multiply by x plus h, and then I get x plus h. So what can I do? Let me pick these ones first. I first multiply these two. So that if I'm multiplying those two first, then I will have x times x squared. Okay, I can begin from here. X squared times x is x cubed. Yes, x squared times h, it is x squared h. Then I come 2xh times x becomes 2x squared h. 2xh times h becomes 2xh squared. And now it is done. H times h squared times x is x h squared. H squared times h, it is h cubed. This is the multiplication from here, that side. And remember, we still have the x plus h. So again, we are going to multiply this expression by x plus h. It is very, very tiresome when it comes to higher powers like 4, 5, and 6. That's why after learning plus triangle and binomial expansion, it is better for you to use them. But for now, let us expand manually. So from here, we need to expand this again. So let me extend my bracket somewhere here. I'm going to say x cubed times x, I'll get x power 4. X cubed times h, I will get plus x cubed h. Now this term is done. I come to this term, x squared h times x, I'll get x cubed. I'll get x cubed h. I'll get x cubed h. Because x squared h times x, I'll get x cubed h plus x squared h times h, it becomes x squared h squared. Now that term is done. I come to this term. 2x squared h times x, I'll get 2x cubed h. 2x squared h times h, I'll get 2x squared h squared. And now the term is done. I come with 2xh squared times x. I'll have 2x squared h squared. 2x h squared times h, I'll get 2x h cubed. Expanding here is where there is a very big issue. I have used this term, so I'm going to this term. Xh squared times x, I'll get x squared positive. And here, right? And here, I'll get x squared h squared. X squared xh squared times h, I'll get plus x h cubed. And then I'm done there. Then h cubed times x, I'll get h cubed x h cubed. H cubed times h, I'll get h power 4. So this is the expansion. Now let us add like terms. Okay. This is x plus h power 4 becomes x power 4 is alone. I should have even started by adding like terms, but it's fine. Here we have xh cube plus xh cube, x cube h plus x cube h. It gives us 2x cube h. Then here I have another x cube h here, and they become 4. There's another x cube h here. No, this is not x cube. This is h. This is x h cube. So I have 4 already, which is 1, 2 plus 2, 4. So plus 4x cube h. And then we are going to look for other terms. Let's go for, I've used this already. So let's go for squares. X squared h squared 1 plus 2, that 3 plus 2, that 5 plus 1, that 6. So plus 6x squared h squared. Then let us go to when we have only one x and cube. So here there are 2, 3, 4 plus 4 x h cube, 4 x h cube. Then we have used every term apart from h cubed. Then now for me we just say here plus h cube, not cube, plus h power 4. This is h power 4. Now from here, this is just the expansion. Therefore, this is the expression for f of x plus h. But the formula says that we need to subtract fx plus h minus f of x. So we can do that one even outside. We can subtract these terms outside and then we substitute the results in the formula. So getting f of x plus h minus f of x means that it is this one, which is f of x plus h, which is x power 4 plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h power 4 minus f of x is x power 4. So x power 4 and x power 4 cancel. This gives us here 4x cubed h plus 6x squared plus 4x h cubed plus h power 4. Then from here you put the formula and say therefore dy dx equals to limit as h tends to 0, 4. F of x plus h minus f of x is already here. So just substitute for it. We have subtracted already. 6x squared plus 6x squared plus 4x h cubed plus h power 4, but we are dividing it by h in the formula. Then from there, we divide all the terms by h. So on dividing all the terms by h, we give us a limit as h tends to 0. If we divide each of the terms by h, we shall have 4x cubed plus 6x squared h plus 4x h squared plus h cubed. Now we need to turn h to 0. When we are turning h to 0, we simply say therefore dy dx equals to, we leave out now the limit, equals to, now where you get h, you substitute for it as 0. Giving us here 4x cubed plus 6x squared h 0 plus 4 x h is 0 squared plus h cubed is 0 cubed. Then you simplify. This term becomes 0, this becomes 0, even that, giving us here 4x cubed. So this is the answer when we are using first principles, which you can even check because you know how to use powers. Y equals to x power 4. So when we differentiate dy dx here, gives you 4 times 1 x power 3 when we subtract the power.